Okay, this is Thor. This is Thor. This is a robotics computer. This is a robotics computer. It takes sensors at just a madness amount of sensor information, process it, umpteen cameras, high resolution, radars, lidars, they're all coming into this chip. And this chip has to process all that sensor, turn them into tokens, put them into a transformer, and predict the next path. And this AV computer is now in full production. Thor is 20 times the processing capability of our last generation Orin, which is really the standard of autonomous vehicles today. And so this is just really quite incredible. Thor is in full production. This robotics processor, by the way, also goes into a full robot. And so it could be an AMR, it could be a humanoid robot, it could be the brain, it could be the manipulator. This processor basically is a universal robotics computer. The second part of our drive system that I'm incredibly proud of is the dedication to safety. Drive OS, I'm pleased to announce, is now the first software-defined programmable AI computer that has been certified up to ASIL D, which is the highest standard of functional safety for automobiles. The only and the highest. And so I'm really, really proud of this. ASIL D, ISO 26262. It is the work of some 15,000 engineering years. This is just extraordinary work. And as a result of that, CUDA is now a functional, safe computer. And so if you're building a robot, NVIDIA CUDA, yeah. Okay, so now I told you I was going to show you what would we use Omniverse and Cosmos to do in the context of self-driving cars. And today, instead of showing you a whole bunch of videos of cars driving on the road, I'll show you some of that too. But I want to show you how we use the car to reconstruct digital twins automatically using AI and use that capability to train future AI models. Okay, let's play it.
The autonomous vehicle revolution is here. Building autonomous vehicles, like all robots, requires 3 computers: NVIDIA DGX to train AI models, Omniverse to test drive and generate synthetic data, and Drive AGX, a supercomputer in the car. Building safe autonomous vehicles means addressing edge scenarios, but real-world data is limited, so synthetic data is essential for training. The Autonomous Vehicle Data Factory, powered by NVIDIA Omniverse, AI models, and Cosmos, generates synthetic driving scenarios that enhance training data by orders of magnitude. First, OmniMap fuses map and geospatial data to construct drivable 3D environments. Driving scenario variations can be generated from replayed drive logs or AI traffic generators. Next, a neural reconstruction engine uses autonomous vehicle sensor logs to create high-fidelity 4D simulation environments. It replays previous drives in 3D and generates scenario variations to amplify training data. Finally, Edify 3DS automatically searches through existing asset libraries or generates new assets to create sim-ready scenes. The Omniverse scenarios are used to condition Cosmos to generate massive amounts of photorealistic data, reducing the sim-to-real gap. And with text prompts, generate near infinite variations of the driving scenario. With Cosmos Nemotron Video Search, the massively scaled synthetic dataset, combined with recorded drives, can be curated to train models. NVIDIA's AI Data Factory scales hundreds of drives into billions of effective miles, setting the standard for safe and advanced autonomous driving.
Isn't that incredible? We take thousands of drives and turn them into billions of miles. We are going to have mountains of training data for autonomous vehicles. Of course, we still need actual cars on the road. Of course, we will continuously collect data for as long as we shall live. However, synthetic data generation using this multiverse, physically based, physically grounded capability so that we generate data for training AIs that are physically grounded and accurate and or plausible so that we could have an enormous amount of data to train with. The AV industry is here. This is an incredibly exciting time, super excited about the next several years. I think you're going to see, just as computer graphics was revolutionized such incredible pace, you're going to see the pace of AV development increasing tremendously over the next several years. I think the next part is robotics. So humanoid robots, my friends. The ChatGPT moment for general robotics is just around the corner. And in fact, all of the enabling technologies that I've been talking about is going to make it possible for us in the next several years to see very rapid breakthroughs, surprising breakthroughs in general robotics. Now, the reason why general robotics is so important is whereas robots with tracks and wheels require special environments to accommodate them, there are three robots in the world that we can make that require no green fields. Brownfield adaptation is perfect. If we could possibly build these amazing robots, we could deploy them in exactly the world that we've built for ourselves. These three robots are, one, agentic robots and agentic AI, because they're information workers. So long as they could accommodate the computers that we have in our offices, it's going to be great. Number two, self-driving cars. And the reason for that is we spent 100+ years building roads and cities. And then number three, humanoid robots. If we have the technology to solve these three, this will be the largest technology industry the world's ever seen. And so we think that the robotics era is just around the corner. The critical capability is how to train these robots. In the case of humanoid robots, the imitation information is rather hard to collect. And the reason for that is, in the case of car, you just drive it. We're driving cars all the time. In the case of these humanoid robots, the imitation information, the human demonstration is rather laborious to do. And so we need to come up with a clever way to take hundreds of demonstrations, thousands of human demonstrations, and somehow use artificial intelligence and Omniverse to synthetically generate millions of synthetically generated motions. And from those motions, the AI can learn how to perform a task. Let me show you how that's done.
Developers around the world are building the next wave of physical, AI-embodied robots, humanoids. Developing general-purpose robot models requires massive amounts of real-world data, which is costly to capture and curate. NVIDIA Isaac GR00T helps tackle these challenges, providing humanoid robot developers with four things: robot foundation models, data pipelines, simulation frameworks, and a Thor robotics computer. The NVIDIA Isaac GR00T blueprint for synthetic motion generation is a simulation workflow for imitation learning, enabling developers to generate exponentially large data sets from a small number of human demonstrations. First, GR00T Teleop enables skilled human workers to portal into a digital twin of their robot using the Apple Vision Pro. This means operators can capture data even without a physical robot, and they can operate the robot in a risk-free environment, eliminating the chance of physical damage or wear and tear. To teach a robot a single task, operators capture motion trajectories through a handful of teleoperated demonstrations, then use GR00T Mimic to multiply these trajectories into a much larger dataset. Next, they use GR00T Gen, built on Omniverse and Cosmos, for domain randomization and 3D to real upscaling, generating an exponentially larger dataset. The Omniverse and Cosmos multiverse simulation engine provides a massively scaled dataset to train the robot policy. Once the policy is trained, developers can perform software-in-the-loop testing and validation in Isaac Sim before deploying to the real robot. The age of general robotics is arriving, powered by NVIDIA Isaac GR00T.
We're going to have mountains of data to train robots with. NVIDIA Isaac GR00T. NVIDIA Isaac GR00T. This is our platform to provide technology elements to the robotics industry to accelerate the development of general robotics. And, well, I have one more thing that I want to show you. None of this would be possible if not for this incredible project that we started about a decade ago. Inside the company was called Project Digits, Deep Learning GPU Intelligence Training System. Digits. Well, before we launched it, I shrunk it to DGX, and to harmonize it with RTX, AGX, OVX, and all of the other X's that we have in the company. And it really revolutionized, DGX1 really revolutionized, where's DGX1? DGX1 revolutionized artificial intelligence. The reason why we built it was because we wanted to make it possible for researchers and startups to have an out-of-the-box AI supercomputer. Imagine the way supercomputers were built in the past. You really have to build your own facility, and you have to go build your own infrastructure and really engineer it into existence. And so we created a supercomputer for AI development for researchers and startups that comes literally one out of the box. I delivered the first one to a startup company in 2016 called OpenAI, and Elon was there, and Ilya Sutskever was there, and many of the NVIDIA engineers were there, and we celebrated the arrival of DGX1, and obviously it revolutionized artificial intelligence and computing. But now artificial intelligence is everywhere. It's not just in researchers and startup labs. You know, we want artificial intelligence, as I mentioned in the beginning of our talk. This is now the new way of doing computing. This is the new way of doing software. Every software engineer, every creative artist, everybody who uses computers today as a tool will need an AI supercomputer. And so I just wish that DGX1 was smaller. And, you know, you know, imagine, ladies and gentlemen, this is NVIDIA's latest AI supercomputer. And it's finally called Project Digits right now. And if you have a good name for it, reach out to us. Here's the amazing thing. This is an AI supercomputer. It runs the entire NVIDIA AI stack. All of NVIDIA software runs on this. DGX Cloud runs on this. This sits, well, somewhere, and it's wireless or, you know, connected to your computer. It's even a workstation if you like it to be. And you could access it, you could reach it like a cloud supercomputer, and NVIDIA's AI works on it. And it's based on super secret chip that we've been working on called GB110, the smallest Grace Blackwell that we make. And I have, well, you know what? Let's show everybody inside. It's just so cute. And this is the chip that's inside. It is in production. This top secret chip we did in collaboration. The CPU, the Grace CPU, is built for NVIDIA in collaboration with MediaTek. They're the world's leading SoC company, and they worked with us to build this CPU SoC, and connect it with chip-to-chip NVLink to the Blackwell GPU. And this little thing here is in full production. We're expecting this computer to be available around May timeframe. And so it's coming at you. It's just incredible what we could do. And it's just, I think I was trying to figure out, do I need more hands or more pockets? All right, so imagine this is what it looks like. You know, who doesn't want one of those? And if you use PC, Mac, you know, anything, because you know, it's a cloud platform. It's a cloud computing platform that sits on your desk. You could also use it as a Linux workstation if you like. If you would like to have double digits, this is what it looks like. You know, and you connect it together with ConnectX, and it has nickel, GPU Direct, all of that out of the box. It's like a supercomputer. Our entire supercomputing stack is available. And so, NVIDIA Project Digits. Okay. Well, let me tell you what I told you. I told you that we are in production with 3 new Blackwells. Not only is the Grace Blackwell supercomputers, NVLink 72s, in production all over the world, we now have 3 new Blackwell systems in production. One amazing AI foundational world foundation model, the world's first physical AI foundation model. It's open, available to activate the world's industries of robotics and such, and three robots. We're working on agentic AI, humanoid robots, and self-driving cars. It's been an incredible year. I want to thank all of you for your partnership. Thank all of you for coming. I made you a short video to reflect on last year and look forward to the next year. Play, please. Have a great CES, everybody.